Hello, so I've just added a new bit to my diagram of what I'm working on, and this is sort of a very simple version of how the renderer is going to work. So what I've got here, I've actually got two APIs. I've got the Deferred API and Direct API. I've got this command buffer and a thread in the middle. Now, in the game, I could just go and use this Direct API and call functions if I wanted to, and that will just wrap up D3D functions. So the first thing I was going to do is just to start the ball rolling was to clear the screen color and be able to set the clear color, and then be able to clear a render target. D3D already has a render target created in the background. When the engine starts, it creates a window, D3D renderer, and the back buffer. So I'm going to use index 0 to be the back buffer. So if you set active color buffer, I've called it this function, with a buffer index of 0, you will get the back buffer, or any non-zero positive numbers will be render targets that you have created from your game project yourself. So in D3D, you tell a render target to clear. In other APIs, you bind a render target and set clear. So I'm going to stick with that mechanism. So if I was just using the Direct API, I would firstly create a clear state. I want to try and kind of encapsulate functionality as much as possible, instead of having lots of single little functions like an API like OpenGL has, for instance. I'm going to try and group together common functionality into structs. So when you say create clear state, this will fill out it'll take parameters of RGBA and depth and the clear flags. The clear flags will be if you want to clear the depth buffer or the color buffer, both of them, or only one, or whatever. The results of this will be stored in a struct which the Direct API will manage, and it will return you an index to that. So a lot of times in game code, people are going clear depth and set blend mode and all this kind of stuff. But a lot of the time the values are constant. So I'm going to just group them together. You create a clear state, a depth state, a blend state, or whatever. D3D kind of has these with the blend desks and the desk, and it gives you back a state that it's created. So it's kind of similar to that API, but I might use group together more functionality depending on what I need. So you create one of those structs, you bind the active buffer, and then you say clear, and you tell it the clear buffer index, and then in the clear function it will look at these values and set up what to do. So that's if you were just doing the Direct API. You'd call these functions, and then behind the scenes it'd call the equivalent DirectX function to achieve the same outcome. The Deferred API is going to be a powerful tool that I want to use. So in here you say set me a clear state, and the function will return almost immediately. Potentially they'll have to set some values, mem copies and stuff like that, but you set this, call this function, and then it gives you the clear state index. This goes then into a command buffer. The create clear state might not necessarily have to go into the command buffer, but just for illustrating the idea, it goes into a command buffer, and then say we call set active buffer. This goes into the command buffer and it stores the parameters. Any other commands like clear, that will go in there, and sometimes you might have bits of data that it needs to copy. So if you want to create a texture, you might have the texture data. So when you use a Deferred API, it'll mem copy that into some persistent memory, at which when the Direct API is finished with it, it will clear it up. So the command buffer gets filled with commands, and then at some point you issue a command to say consume the buffer, or maybe the consumer thread can check if there's anything in it. You wake up the consumer thread on a semaphore, and then it will just go through these commands and call the equivalent direct API function with the parameters that it has copied. So the reason for this is that in the game I could just call any rendering function, no matter how expensive it would be in terms of the D3D API cost. The game can just call a function, get a value back almost immediately, and carry on. And the command buffer can then defer when the DirectX calls or OpenGL calls get made or whatever at a later date. So there's two things here really. The direct API will wrap up an existing graphics API. In this case it's going to be D3D 11, and I could use these functions and fill out the OpenGL functionality, or on other consoles you have graphics APIs for each one, or with slight differences, but under this API I can unify the functionality and be able to use it agnostically in the game. The Deferred API is a command buffer system for my graphics API to make these calls. Say in D3D for instance, instead of having this command buffer, I could actually build D3D command buffers directly, or I might do a simpler approach. It depends what it's going to entail, which I don't quite know yet, but I have used this approach before. And essentially what happens is this consumer thread owns a D3D device and swaps buffers and all that kind of stuff, and that's a dedicated thread just to the graphics API. I know you can have deferred and immediate context and stuff in D3D 11, and I need to look into exactly what those are, because I haven't used D3D 11 that much. But yeah, this is a diagram of what I'm going to be doing, so I'm going to get on with this now. I'm going to create these functions basically. Firstly I'll do the direct API, and I'll probably call that from in the game and test that it's working. Then I'll do the deferred API, and then for any subsequent API calls that I need to add, like bind textures or create vertex buffers, I will implement the direct API and the deferred API at the same time. So hopefully it shouldn't take too long. A little bit of extra work to add the extra functionality for the deferred API, but in the long term it gives me the flexibility of having a completely separate thread which the game runs on, making draw calls, but it doesn't actually incur the D3D draw call hit, and allows me to parallelize the game and the renderer. It allows the renderer then to, even in the worst case, if I can't create commands on multiple threads, in the worst case I can have 16 milliseconds if I'm running at 60 frames a second to just consume draw calls. So the consumer thread is waiting for the commands, and the game or whatever's creating this deferred command buffer will be the producer thread, and this is a producer and consumer system. I should really add that to the diagram to make it a bit clearer. One thing that I originally did was create a clear state here with the RGBA floats value to clear the depth buffer 2 and the flags, and then in the command buffer API, say create clear state, so you fill out one of these structs, pass it in, and or in the direct API at the moment, and then I've got this internal one, which at the moment is the exact same values, but I'm going to change that now. So this struct, the internal one, is going to be more optimal for the rendering API that is being implemented. So in this case, D3D11 takes an argument of an array of floats like this. So I'm going to do that. Not that it's actually any different to this, but in the future these structs will get filled up with maybe sort of D3D render target views or whatever, just so when the direct API calls them, it'll be quicker and more direct. I realised that I don't have to create a direct and a command buffered version of create clear state. So I create this other namespace called shared. Oh no, actually I shouldn't do that, because I don't need to call this. I can call this from anywhere, because all it does is fill out some structs and return me a handle. It doesn't use DirectX, basically. Some of these functions are going to do my own stuff. The same with set active color buffer is also not a command buffered one, because all it does is set the depth and it sets the active color buffer. Okay, so what I've done here is I realised that the create clear state and the set active color buffer don't actually do anything D3D related. The clear state just allocs some memory and sets some values in the internal clear state struct and stores one in my clear states, and the set active color buffer sets the active color buffer and the buffer index. Now, mainly I want to use just the command buffer API primarily, but the direct API is handy to have for debugging. So I can just redefine this by a macro, say for instance So then I can go like renderer clear, and then if I have this on a if def, then I can jump between direct and CMD or CMD buff, and just use renderer clear from in the game. Now the only confusion will be that renderer, then these won't be part of the renderer, so the naming convention might be confusing, but at the moment I don't want to duplicate these because I don't need to, so I'm just going to leave them like that. What I've done now is I've created the clear state struct and clear state function. The clear function, so I've created a clear state with RGB, RGBA and depth value, and then clear color buffer flag. So it should clear the color buffer to green and the depth to 1, but there's no depth buffer and it's not clearing depth buffer. I create the clear state and I should return me an index, and then I call clear. I'm using just the direct API at the moment to test this, and this is in the engine project. So what I need to do is fire up my game project and then test if that has worked. It should have done because the code is only simple, so if it hasn't, then I'm an idiot. So that worked. At first I hadn't even built the engine, so that's why I had a little trouble. But yeah, that's using the clear state now and clearing the buffer. So I'm going to continue on and make this happen in the command buffer, and then I can start calling that from inside the game. So I got the D3D window rendering by calling the graphics API stuff from inside the game. On some graphics APIs, like OpenGL, you wouldn't be allowed to do this, I think, because the OpenGL rendering context needs to be created on the thread you're running on. So that's why the command buffer system is useful for D3D, especially D3D11. There's a lot more flexibility with using a multi-threaded D3D device and writing command buffers and things like that on multiple threads. But some APIs, like older ones, don't have that functionality. It might seem a bit silly to going through all this legwork when I'm just making a Win32 D3D app, but this is about sort of best practices and writing an engine that's going to be easily ported to lots of platforms. So I've got to go with the lowest common denominator, and that's like OpenGL2 or D3D9, where you only have single-threaded context. I just realised that set active colour buffer does actually have to go into the direct and the deferred APIs. I've called this namespace defer instead of command buffer because this is the deferred API and the command buffer will be hidden behind the scenes. But this has to be called because this will insert this index into a list, because in a command buffer consumption time we might actually have a number of set active colour buffers. So yeah, basically I'm making this all up as I go along, so sometimes I'll do stuff wrong. So what I have here now is a quick bit of code for the Deferred API. I defined an enum of commands, and these are going to be the name of the commands: cmd clear, set active, color buffer, present. They're the commands I have so far. I've made a struct which is called deferred command, which takes a U32 of command index, so every command needs to have a command index. And then I've made a union of data. This might change, but at the moment there's only one type of command. They both supply an index. I'm hoping with having the create state things that a lot of this is done through indices, so there's not a lot of passing of parameters. I have done this for OpenGL before, and OpenGL has a lot of parameters it passes into functions, and there was a lot of copying of data and a lot of different commands in here basically. So this could grow, and I might have, a certain function which takes a number of parameters, so the union will include a struct which has those parameters in, or I might have the command already defined as a struct somewhere. So basically what happens is when you come to call a deferred clear, it sets the command buffer, which is just an array of commands with max commands at 1000. I've got a position which I'm incrementing and wrapping, so this is a ring buffer. So in theory you just need enough size so that the GPU consumes quick enough, and then it's almost like you're chasing the tail. You're producing commands and then the GPU's consuming them, and once you're running in Harmony, no need to swap buffers and stuff like that. Much nicer, cleaner approach. So it's got this put pos, so I put a new command in the put pos and increment that, and then set active color buffer puts his command in, and also its buffer index, and then present doesn't even have a data index, it's just a void function. So those three have been implemented, and now I need to spawn a thread for the renderer to live in, or I could do it in the Win main for now. And I'm going to use a semaphore to wake up the command buffer if it was in its own thread, but I don't know whether to put it in its own thread or to just have the renderer and the window live inside the same thread. I'll have a think about that now. So I'm just tidying up the code here, and some things to note. At the moment I've got my clear states, color buffers just as static arrays. That could change, but I don't expect to be having a lot of these objects. Things like textures and vertex buffers and things I imagine I'll have a lot of, but they'll only really be handles, so this data should be fairly small, even though it might seem like I'm allocating lots of static memory, but It can change in the future if I need to, but I think it will be okay just like this, and I don't want to really be having to, I guess you wouldn't be doing it that much, but deleting and reallocating these arrays, really they just store pointers to memory D3D will have allocated, or I will have allocated myself through another graphics API. I've got the APIs for all this stuff filled out now. I've got the direct API, the deferred API, and I filled those out. Execute command function. It's just a switch statement, which is going to call functions. It might seem slow, or you might think it might be slow or unnecessary to do this, but I'm going to see how it goes. I wrapped up the deferred API, so I've got these clear set active color buffer and render represents, and then the execute command calls the direct version. At the moment, I'm just going to call this after I've made the draw call, so it's almost like I'm calling it in the same way, but essentially I will defer it, so this execute command, this consume loop executes the direct ones consecutively from the command buffer. So I'm just going to change the clear color to go with classic magenta. So after I call render represent, actually for the time being I'm not going to have that consume. I'm just going to call that from inside the renderer present. Okay, so it briefly worked, but then it crashed. So I'm going to see why that is. Right, I've got it working. So it's set the color to pink. It's using the Deferred API. The only things left to do, I'm going to test the timers, just to change the color of this window, because I haven't really used them yet. And then the next thing would be to move the D3D renderer into its own thread, so it's just spinning, spin locked on a semaphore, waiting for something to wake it up. And when you call the consume command, that'll wake up the thread, and it will start dispatching those commands onto the real D3D device. Another thing I need to do is that it just crashed on shutdown then, which is probably because the producer thread is trying to call D3D functions after the D3D device has been destroyed. So I need to synchronize that as well. So what I have, no, what I've got now is the D3D renderer clearing the screen every 5 seconds. So the timer code's working. I did have a little problem where it wasn't initialized, so the performance frequency was 0, resulting in me getting 0 times. But it seems like the timer's working. I've called this from the Deferred Context API from inside the game, and everything's starting to behave kind of how I want it to. What I'm going to quickly do is just change over the deferred context to the direct one, just to see if I can I can use it, because it will be useful to maintain these two. It's a lot of code to maintain, but I'm just working through this project slowly and steadily, and doing things what I think are the right way. So yeah, got changing color screen, timers, threads, D3D renderer, the inner sort of beginnings of the renderer and the command buffer system. And that's me done for today.